And welcome everybody to the Daily Space Weather. Some spectacular imagery here for you. The last 24 hours of activity, including imagery here from the SDO. That's this center image you see here. That's the sun in 304 angstroms, ionized helium, ultraviolet light. Also, we've got the LASCO C2 and the LASCO C3 coronagraphs here on the helioviewer.org imagery. Here's a close-up of the same data here. Now we've moved in beyond the LASCO C3's zoom. And multiple M-class flares happening in the past 24 hours. We've got sunspot 2824 here in the northern hemisphere. And a new sunspot also has risen, sunspot 2825. 2824 has remained pretty stable here. We can expect to see a reduction in solar flaring activity as the Earth-facing quiet effect goes into effect. And sunspots have a tendency to release less significant solar flares from Earth's perspective due to the angular nature of the emission spectra of the sun's photosphere. It's a heavy metal star. Leave us a comment if you think the sun listens to Megadeth. Leave us a comment if you think Megadeth is underrated. So here we are in one of the ionized iron wavelengths, 335 angstroms. Fantastic imagery of multiple solar flares here. It's spectacular. I'll let it play through one more time here. And 335 angstroms is a good wavelength to view solar flares. Here's another extreme close-up of that sunspot 2824, the one responsible for most of the recent activity. We've got multiple solar flares in the past 24 and 4 coronal mass ejections headed Earth's way. We knew how busy we would eventually get as a result of solar activity, so here we are. Next, a close-up of sunspot 2824 in carbon. So now we're looking at, instead of ionized helium like the 304 angstroms, now we're looking at ionized carbon. And it looks like a lot of carbon being synthesized right around that sunspot. It's called nuclear fusion, folks, and it's clearly happening right there before your eyes on the surface of the sun. It is not outlandish anymore to believe that all stars are able to make all of the elements on the periodic chart on their surfaces. If that's blasphemy, we apologize. It just happens to be the observational reality of things. Let's take a look at what's going on from Lagrangian point 5. So there's a spacecraft out at Lagrange point 5 known as Stereo A. And when you view the sun from Stereo A, the Earth is off to your right. And here are some coronal mass ejections for you. So we forecasted this event beginning to start about 3 days ago. And here you can see 4 coronal mass ejections. So we called it before any ejections actually happened here. And while we can't get into the specifics of how coronal mass ejections are forecasted, they are forecasted by our channel. Most of our content is on YouTube. Check out smashamash.com, become a patron for the earliest alerts and so on. Patreon.com/smashamash. Here's one more close-up of sunspot 2824 in 193 angstroms, another one of the iron wavelengths. And this is ultraviolet light emitted by very, very hot gaseous iron in the atmosphere of the sun. And the whiter the colors you see there, the more iron of this ionization type are at that location. So 193 is another great wavelength that shows you a lot of features. It shows you, you can also see waves rippling across the surface of the sun associated with these solar flares. great indication that the sun has a surface. So next, looking at a diagram of the solar system here, this is where things are now. There's where things are in a week. We'll show you a star chart as well. There's the current situation over my head. I'm located in Lehigh Valley, Pennsylvania. And the 10.7 centimeter radial flux, the most proportional data set, the sunspot number is now up to 76. Here's the 1 year chart of the 10.7 centimeter radial flux. It's the black line. The red line is the sunspot number. And the 10.7, the F107 or 10.7 centimeter radial flux, 2,800 megahertz radial flux is the most proportional feature to sunspot number. Now, we don't have the full Enlil forecast yet for the coronal mass ejections. It looks like it's showing 3 of them, one off to the northwest, one somewhat striking the Earth's geospace, one off to the southeast, and the 4th one not yet modeled. So this is on the Space Weather Enthusiasts dashboard if you want to go look at it yourself. There are other forecast models as well. We won't get super in-depth into it as it's too early to do so. Let's take a look at global seismicity. What's been shaken? What parts of the Earth have been quaking? Recently, we saw the 7.0 magnitude earthquake drought end at a 7.4 in China. On the eastern portion of the Tibetan Plateau, here are the 4+ magnitude earthquakes, a quick visual analysis. Those are all the earthquakes over a magnitude of 4 or over. And there are the 5+ magnitude quakes. Nothing over a 6 magnitude in the past 24 hours. We'll scroll up the list here for your convenience. There were some deep quakes such as that 5.3 near Wallace and Futuna. That was at nearly 400 kilometers and a 5.3 magnitude. Also a deep quake at Fiji, the deep quake capital of the world, a 5.0 at 548 kilometers depth. Argentina saw a deep quake at a 4.5 magnitude. And another deep quake at a different location in Argentina. Also, Philippines saw a 5.5. I think that was the largest of the past 24 there. That was 104.7 kilometers depth. So some deep quakes. Let's check volcanoes, and we've seen a major uptick in volcanoes, including Stromboli now erupting. So the volcano for which Strombolian eruptions are named has now been erupting in the Aeolian Islands of Italy, including a lava flow and rock falls. Also more paroxysms at Etna, so lava fountaining events at Mount Etna on the Isle of Sicily. So historic volcanic eruptions here, and also Fagradalsfjall has now begun to leak into the next valley. We'll get to it in a minute. Yeah, so Fagradalsfjall has indeed turned into a shield volcano before our very eyes. It went from a cinder cone to a shield volcano by filling up the entire valley in which it is located. So now it's spilling out into neighboring areas, such as Nataji, as lava flows out of its own crater valley into adjacent regions. Also, Abiko producing a 14,000-foot ash plume, Suwanosejima 7,000-foot ash plume there, Sangay exploding 21,000-foot ash plume there, Revenador 14,000-foot ash plume, Sabancaya 27,000-foot ash plume over the Peruvian Sabancaya volcano, Nevados de Chilean exploding 14,000-foot ash plume there, and the biggest report of the day for volcanoes, Nyiragongo in the Congo has produced a 45,000-foot plume of ash approaching stratospheric levels. And this volcano features extremely watery lava, which flows very quickly. The capital city of Goma was already damaged from the 2002 eruption. And lava is making it all the way into the capital city, including at the airport, so it's a disaster. People are fleeing and crossing the border into Rwanda and so on. Hopefully everybody gets their stuff in order there. Hopefully resources are appropriately allocated. Here's one of the images, and it's a huge area where a fissure collapsed and allowed a lava lake to drain. And when this causes lava lakes to drain, it's less than optimal for the capital city of Goma. Continuing on, we'd like to remind our viewers to not pole vault the caldera. Now, Nyiragongo's caldera is probably too large to pole vault, which would be a suicide mission. But don't pole vault any calderas. It could be unhealthful. And we'd prefer for you to watch the videos, so don't pole vault the caldera. And check out smAsho for more details about Steve Stimpak's saga. So here you can see these solar flares. There were 2 M-class flares here and multiple C-class flares over the past 3 days. 1, 2, 3, 4, 5, 6. Like 10 C-class or higher flares in the past 3 days. There's the GOES X-ray flux. Now, these X-ray flares cause radio blackouts. They cause a portion of the ionosphere to essentially absorb your radio signals instead of refracting them. So people think that the ionosphere reflects radio signals. It actually doesn't reflect radio signals, folks. What it does is it actually absorbs and re-emits them. But I guess that's splitting hairs at this point. And if you look up the deabsorption regions, these will coincide with solar flare events. This is how the sun nearly immediately causes. So about 8 minutes after a solar flare happens on the sun, the light arrives at Earth. And when it does, if it's in the form of a C-class or higher solar flare, it will blacken out part of the ionosphere. So it absorbs portions of the radio signals instead of absorbing and refracting them, absorbing and re-emitting. It just absorbs them instead. Basically opening a radio hole in the ionosphere. And of course, we saw multiple radio holes open in the ionosphere with all of the solar flaring over the past couple of days. The most recent one just occurred here also. Right over the Arabian Peninsula was the center of that. It was about noontime at that part of the planet. Next to GOES proton flux, and we don't see any spikes. And we could see some spikes. We're expecting the coronal mass ejections to arrive here at Earth in as little as 2 days, as there was a mixture of high and low speed coronal mass ejections coming off of that series of events. And so, again, 4 coronal mass ejections over a very short period of time. We could see spikes in the proton flux, so we'll keep an eye on it for you. And when I say ion, well, the pun is intentional. The GOES magnetometer over the past 3 days. Pretty normal levels of GOES magnetometer here. And let's take a look at the heliospheric current sheet. Earth is in a North Pole current sheet right now, shown there in green. And you can see the massive magnetic bubble right in this area right here from sunspot 2824 and sunspot 2825. Also, we see some progression of the solar cycles. We'll get to it. First, the line of sight ecliptic plane field plot. It's essentially the same data. It's the polarity of the heliospheric current sheet. The solar wind puts out a constant sheet of current in the form of solar protons, mainly hydrogen nuclei. So here's a line of sight coronal hole plot, and we can see some progression of the solar polar fields here. And what we're looking at is part of the north solar polar field is beginning to make its trek southward as the solar polar field reversal process happens. It's a little bit hard to see from this perspective. This shows you the blue lines here are the sun's B field. And the green is North Pole-oriented coronal holes, and the red is South Pole-oriented coronal holes. I would also note that there are trans-equatorial coronal holes just about to rotate into the Earth-facing zone here. South of sunspot 2824 and 2825, you can barely see them. but those will come into view in the next day or two. Yes, it's a coronal hole forecast. Also looking at detected filaments, this coronal mass ejection event is largely complete, folks. Most of the plasma in the Earth-facing zone has already ejected out into the solar system. Don't expect to see many more coronal mass ejections. It looks like that series of events is complete. And I don't know how this sunspot didn't get a name yet. That's been there for well over 24 hours now. That's sunspot 2825. I don't care who says anything about it. It's sunspot 2825. Update your live journal. KP index is currently at 1. That's a measurement of global geomagnetism. Calm conditions for that. Let's take a look at the real-time solar wind. Solar wind very weak here. Solar wind density all the way down to about 2.5 protons per cubic centimeter. Solar wind speed 428 kilometers per second. Still slightly elevated at the end of a coronal hole wind stream. Let's take a look at the geospace. Here's a magnetosphere movie. It should be 4 hours of data. And we see most of the magnetohydrodynamic pressure here on the magnetotail side to your right. The sun would be off to your left. And you're looking at about a dozen Earth diameters of magnetohydrodynamics, the space weather modeling framework. Pretty uneventful solar wind-induced magnetism there. Next, looking at ground magnetic perturbations here, coming a little bit closer to home and looking at changes in the Earth's B field, or geospace delta B. So the Earth currently has 2 north poles, one over Canada, one over Siberia. The South Pole has left the Antarctic continent and is someplace down here south of Australia. And you can see some perturbations around where the South Geomagnetic Pole is, as well as the Canadian North Pole and the Siberian North Pole. That's 4 hours of data, just like the previous magnetosphere movie. It's all courtesy of University of Michigan. Shout out to our viewers from University of Michigan. Cheers. Next, we're going to stream live. And we've decided to stream live for our cosmology segment. Welcome to our Twitch viewers. Thanks to our new followers over on Twitch. And thanks for tuning in. Twitch.tv/smashamash is a fantastic live streaming platform. We love twitch.tv. And I am a gamer, believe it or not. I do play Wolfenstein Enemy Territory is a game that I play regularly. Thanks to our YouTube viewers as well. And if you didn't watch yesterday's video, Daily Space Weather Supplemental video, well, you should probably check it out. It was hosted by Bono. And shout out to Eugene Bagashov for attending yesterday's premiere. We'll be interested in hearing about your sun blog soon. So here's a little tidbit from yesterday's Daily Space Weather Supplemental. Wow! Incoming. Because there's incoming, folks. Some of that ejecta will strike the Earth. So anyway, watch the video. Next, thanks to our patrons who knew about the coronal mass ejections before they happened, because they provide a financial incentive for us to give them advanced information. So thanks, patrons. If you'd like advanced information yourself, become a patron at patreon.com/smashamash. Help us to continue to expand our operation and roll back benefits to you, the viewer, and increase the probability these videos will continue to exist and remain publicly visible. Also, check out our own website. Support our content via our merch, perhaps. We've got 3 stores there. The smAsho merch store is the newest one from Redbubble. There are also 2 Teespring shops, linkable from our homepage, smashamash.com. Smashamash.org will redirect you. So let's do the cosmology segment. Pardon all the promotional material at the beginning. Today's cosmology segment's fascinating as always. How about the red blood lunar eclipse happening on May 26th? I'll let the article scroll here. Are you aware that the moon appears 12% smaller at its apogee and 12% larger than at apogee at perigee? Yeah. It's like 50,000 kilometers closer at perigee. And that's what a supermoon is, as the moon has an elliptical orbit. In any case, there is a total lunar eclipse coming up, and this article here is all about why lunar eclipses appear red, and ultimately it's because of sunlight shining through the Earth's atmosphere. It's the same reason Sunsets and sunrises can appear red. It's because of the refraction of the electromagnetic spectrum in the visible light portion. And there are some diagrams explaining why total lunar eclipses look red. It's not because we're all going to die. It's because of the Earth's atmosphere. Let's pick a random number here and go to the Neil Gorell Swift Bat X-ray Observatory. Today's random number is 773. And that coincides with an object known as XTEJ1807-294, a low-mass X-ray binary. Let's take a look at it. Here are the X-ray transient outputs. And interestingly enough, it had a moment where it stopped putting out X-ray for a while and then restarted just in a normal-looking cyclic pattern there, as if nothing to see here, folks. It just emitted X-rays for all but one of about the last 16 years. And there is the 30-day chart. You can see it is a little bit irregular there in its outputs. Let's take a look at this low-mass X-ray binary. Probably something like a white dwarf. And it looks like we've got a pretty lousy view of this. We are streaming live, so let's take a look at it on infrared light. So there it is in infrared, looking pretty dull. And it's in a very busy part of space. This is probably why it's going to show up in X-ray and not a lot else. And there it isn't on the XMM Newton and the Chandra. So it's a pretty dark spot here, but it is indeed an X-ray source. Does it show up in blue light? Kind of. Again, it's at a very busy part of space, probably near the galactic center. And as we zoom out in the blue light spectrum, you can see how close to the center of the galaxy that must be there. So it's not showing up in UV. How about in red light? And you can see there are a series of objects there. Let's take a look at, let's see if Pan-STARRS has taken a look at this. Pan-STARRS typically has some pretty high res. And it's really at a dark part of space there. Looks like there's a very bright blue star, could be in the foreground. In any case, that's today's quote random and quote cosmic object. Low-mass X-ray binary XTEJ1807-294. A catchy name. And if you want to look up your own favorite transients, head to the Neil Gorell Swift Observatory, and maybe you're interested in the core of the Milky Way galaxy. Just type in SGR space A, and you'll get Sagittarius A star, the core of the Milky Way galaxy. There are the X-ray transient outputs from it. Continuing on to talk about Salamanca. This photo came from Salamanca. Not that Salamanca. Salamanca, Spain. Shout out to Cesar Vega Toledano for this fantastic image of, looks like an acacia tree perhaps, and the Milky Way galaxy. So an interesting fractal of trees here. They used a flashlight to illuminate the area behind the tree to allow this silhouette to appear on the background of the low sky polluted region here, showing the Milky Way galaxy. So actually it's a distinctive grove of oak trees, and those are indeed distinctive. They must have pruned them in a way to make them even more distinctive, but in any case, there are the dust lanes of the Milky Way galaxy. And some oak trees, some odd oak trees, I might add. And that's today's cosmology segment. Thanks for tuning in, viewers. Wherever you viewed it, don't forget to press like and subscribe. And we'll have to say goodbye to Twitch. We'll bring it back for the meteorology segment. Continuing on with the daily space weather, we're going to talk about Van Allen belts next, and the electrons that are in them. The electrons that are located in the Van Allen belts. Here at the Smash News Network, least busted name in news. We're interested in facts. Here are some. We don't see charging hazards, as lots of electrons out there in space can charge up satellites, causing them to shut down and causing communications errors as a result. Here are the 2 mega electron volt electron flux numbers over the past year. You can find that graph at solon.info/solar. solon.info/solar. And here's a 3-day chart. We got very briefly into warning levels yesterday as I forecasted, and we're expecting a little higher levels of electron flux today. So don't be surprised to see some communications errors once again. And there is still a possibility of solar flares despite the Earth-facing quiet effect. We're just not expecting as large of flares, especially in the next couple of days, as sunspot 2824 is directly Earth-facing right now. So Noah and I must have agreed. We expected to see a little higher levels of electron flux there than we did. That's the forecast model for electrons. Here's a total electron content forecast visualization. It's showing you electron density for the entire air column from your GPS handset all the way up to a GPS satellite. And when they have to communicate through a lot of electrons, you get errors. And the most errors occur around the equator at noon. I'll let it play through a second time here. And this is pretty accurate, folks. I've tested it out on the bike myself while using my GPS. And if you turn on location accuracy to use Wi-Fi hotspots to help location accuracy, it will help reduce your GPS errors. Next, a diagram of the atmosphere in order to show you where the F layer is. It's this right here, the F ionosphere. Is the ionosphere F'd? Not really. It is looking a little anomalous here, though. So we're looking at 2 days of data of the vibrational frequencies in the ionosphere in megahertz. And we are indeed seeing some anomalies here. So I had to reload that for some reason. It stopped playing. And we see very localized regions of vibrational frequency in a normal range here. But at the South Pole, we're seeing some sort of odd charge downs. Really, at both poles, we're seeing some charge downs of the ionosphere. It's frankly looking a little bit wobbly right now, folks. And I'll let this move forward until around now. There we go. And here's the latest image from 10:15 Universal Time. Just keep in mind I had it centered on 180 degrees longitude there instead of 0 degrees where I usually have it. For some reason, this map keeps resetting itself. Anyway, there's where things are at 10:15 Universal Time. Still looking a little bit abnormal there around the poles. Next, we're going to do a meteorology segment. So welcome back to our Twitch viewers for the meteorology segment. And we stream this live to make sure it's timely and integrated to the daily space weather video. So check it out, folks. It's so hot that it's cold in places like Colorado, Utah, Wyoming, Nevada, Oregon, Idaho, and Montana. In Montana, where we're expecting 2 feet of snow to fall by Tuesday, May 25th. So is it a year without a summer? In some places, it certainly looks like it, as we're less than 30 days from the summer solstice. And let's just say it's very cold in Greenland. We'll show you data on that momentarily as well. That's the GFS snowfall forecast for total snow accumulation, according to Tropical Tidbits, through Tuesday, May 25th at midnight Universal Time, which technically is still Monday. Let's move it forward one more spot there. There's 6 Zulu, which is 1 a.m. Eastern Daylight Time on Tuesday morning. 1 a.m. Eastern Daylight Time on Tuesday morning, we're expecting to see 2 feet of snow having fallen, according to the GFS forecast, in that portion of northwestern Montana. Apparently it's so hot that it's cold, folks, so make sure you don't burn a tire. Make sure you reduce your carbon footprint today because it's so hot that it's cold. Oh my God, sea levels are going to we're all going to be swept up by the ocean, folks. Because, pardon my sarcasm. Next, looking at the jet streams of the Western world, and check out how chaotic the jet streams are over the U.S. right now. Extreme meridional jet stream flow, where it's flowing roughly north to south, instead of west to east in its normal pattern. Here's the surface wind scenario for the western world. Here is the eastern world in terms of surface winds. We've got some strong winds there east of India. Also in the Aleutian Island chains, there's a powerful low out there. In the outskirts of the Aleutian Islands, you can see this counterclockwise rotation indicating a strong, powerful low-pressure system there. Also a series of powerful low-pressure systems in the southern Indian Ocean. Continuing on to lightningmaps.org, it's where I go when I hear thunder. It helps me to convince the natives that I'm Odin and that I've caused the lightning. And it looks like we see some thunder rolling in here near Monument Valley. Near Santa Fe there. Near Las Vegas. Yes. Hey, Las Vegas. There's thunder rolling in. If you hear thunder, check out lightningmaps.org. It could save your you-know-what. Tell you when to go inside. One of the only things that cancels a bicycle race, folks, is a severe thunderstorm. Here's that NASA GOES lightning mapper showing us a visual of the lightning over the past about 6 hours. I'll let it loop through a second time. We don't want the video to be too long, and so we try to keep it concise and pack a lot of information. We've only got 28 days and 16 hours until the solstice. What are you going to do with your final less than a month of spring or fall? We'll be streaming live at the moment of the solstice, so join us for that. We'll be streaming live on June 20th at 11:32 and 9 seconds. That's 11:32 p.m. Eastern Daylight Time. Join us for that. We'll be on multiple platforms. And check it out, folks. Look at how hot it is in Greenland. Now, you realize that at the solstice, portions of Greenland see sunlight all day long. So it must be hot there, right? Oh, it's negative 13 degrees Fahrenheit in central Greenland. Let's go to the southern tip, just the tip. Oh my God, it's a heat wave down there, folks. It's 13 degrees Fahrenheit in southern Greenland. It's the whole island is going to melt, and Obama's house is going to be underwater before we can even say fraud. Anyway, there's the current temperature data. We'll advance this into tomorrow. And here's where the European forecast expects temperature to be at 1 o'clock daylight savings, 1 o'clock Eastern Daylight Time tomorrow on Monday, May 24th. Continuing on, here's the U.S. Doppler radar map. Lots of precipitation west of the Mississippi. We also have odd storm tracks. We've got lots of Doppler radar data here moving south to north, not the normal progression, and it all has to do with that extreme meridional jet stream flow over the U.S. Here's what's going on in the cloud layer. It's still too dark to show the visible satellite. Here's the water vapor map. Again, cloud layer, water vapor, and the Doppler radar. Hopefully that gives you some insight into what's going on in the weather. The water vapor map is the key when the Doppler is not providing the data you'd like. And that's today's meteorology segment. I've been your host, Dan, a.k.a. smAsho. Again, visit our links. Talk to you soon. Bye-bye, Twitch. Let's continue on with the daily space weather for bonus features, which will start in the form of the latest hydrogen alpha imagery from the ground-based observatory at Udaipur, India. Yes, there's the latest data on that. Again, most of the filaments have already ejected, at least from the Earth-facing zone here, folks. Don't expect to see a whole lot of additional coronal mass ejection. The event is largely complete. Sunspot 2824 still harbors the field complexity for major solar flares. Just expect them to not be as major in the next couple of days due to the Earth-facing nature. Let's keep an eye on Sunspot 2825 as well. Here are the latest close-ups in ultra-high res, and you can see a series of umbrae surrounding. This is actually gained in complexity here. So there's a series of umbrae. These are all South Pole umbrae surrounding this North Pole main umbra, and that is an indication that sunspot is not yet through with its activity. So while this main umbra looks like it's degraded over the past 24 hours, it's still gaining in complexity. This is also a beta class sunspot, I think. Let's take a look. Sunspot 2825 is beta class. So this is a South Pole umbra, and this is a North Pole umbra, this larger one right here. So that is a beta class sunspot, and we're seeing some odd field configurations here around both of these sunspots. Again, there's 2824, and we'll close things out with some additional imagery of those areas. Fantastic view here of a full disk sun from the Solar Dynamics Observatory in 304 angstroms ionized helium. Again, don't forget to check out our video from yesterday, the Daily Space Weather Supplemental, the initial analysis of the coronal mass ejections. There have been 4 of them, and they're mainly associated with this sunspot here, sunspot 2824. Here it is in 94 angstroms, one of the 2 highest temporal resolution wavelengths from the SDO. And here's the other highest temporal resolution wavelength, 131 angstroms. We'll close the video out with that. Splentacular imagery here of sunspot 2824 and its C and M class flares. In any case, thanks for tuning into the Daily Space Weather. Congratulations on finding out that our channel exists. Welcome to the Neo Renaissance. Visit our sites, and may that solar wind be at your back.